So without further ado, I'd like to invite up the superior colliculus. All right, so this is Team Superior Colliculus. There's always, I think, some confusion, especially for those people who are not in majors in brain and cognitive science. So why don't you talk a little bit about your team name?
Okay, so Superior Colliculus is the Superior Colliculus is the part of the brain that deals with eye and head coordination. So when the head moves around, the eyes can still focus on what they're trying to focus. And so we thought this was an appropriate name, partly because we saw it in an artificial intelligence book and thought it was the most amazing word ever. But also, our robot has a moving camera, or moving eye. The eye consists of a camera and 3 IR sensors. So you basically have a little creature walking around and looking around itself and finding where it goes.
Okay, well it looks like Danny's about to start the robot. So
We'll reset that.
right, so it's worth mentioning at this point that is simply display time. Our official timer is right there. Thank you, sir, for the catch. So again, with the calibrating of the, this is a great plug for analog devices. We are currently calibrating the analog devices gyroscope. So I noticed that you have a tri-wheel robot. Did you encounter any difficulties while building it?
Okay, so the tri-wheel robot, while it was a great idea, we found out that it was not as easy to find motors that would fit it's kind of stuck right now. Don't worry, it'll go back up.
There it goes, hey.
So with the 3 wheels, you have to find the right motors and the right amount of, a good amount of power. But once it gets together, it's a lot easier to program, and it's actually pretty simple to control.
Right, so if I understand the diagrams correctly, and especially looking up over there, you have a passive gate that just allows balls to come in as soon as you run over them. Is that right?
Right, so the way that we collect balls is we have a gate that it's called a passive gate because once we drive over a ball, the gate will flex back and will allow the ball to enter, but the gate will remain closed so the ball cannot go in the other direction. So right now, in the wandering mode, once we see a ball, we aim and go towards the ball and drive over it and capture it. But then when we want to score, we can release the gate and.
Well, I just want to mention the grace with which it is traversing the course. I mean, you'll notice that it's not touching walls all that much. As I was saying, that it actually seems to do a very good job of avoiding the walls. Are you using the infrared sensors, vision? Oh, looks like that is. And I don't know if it was possible for other people to see, but you guys actually give it, you don't just hold the passive gate shut, you give it a little kick right at the end.
Right, we kind of added that on about 5 minutes before we turned into robots.
So are you using the infrared sensors to get around that are mounted on your kind of, I guess, the colliculus of the robot?
Right, we have infrared sensors and they track how far away a wall is, and when it's a certain distance away, we tell the robot to back off, but continue on its path. Actually, the way that our robot drives around and thinks is a combination of different motivations. They're called schemas. So basically, you have kind of parallel goals. So we have parallel motivations going on. We have the goal to drive around and collect balls. At the same time, we have motivation to avoid obstacles, and then if we hit a wall, we obviously have to back up. And the trick is balancing the weights that we give each of these schemas. So you get a more or less complex looking behavior. That's the word they use, relative intelligence.
Relative to what is the question? Oh, so it looks like You got another one there? Hard to tell. I also want to mention the reason, for those of you that don't know, that I can adjust the field without fear is that the blue line, which is at a set height throughout the field, can be used to filter noise out. So if Gleb and I were wearing red shirts, it would not think we were balls because we're well above the blue line. So it's able to just say, hey, ignore this, it's not part of my world. And if teams don't implement that, then they see a lot more red balls. So it seems like do you now have bump sensors on the gate? What's it trying to do now, it seems? So what inspired you to use a servo on your camera?
Our original idea was to have this continuously spinning device just to make it look awesome. It seems like gold.
Three balls! Three balls! Oh!
First goal was 20 minutes before we had to submit the robots. This is
well, now we're coming to the moment of truth. Will your robot stop? So now it looks like entering the 10-second grace period. Oh! Hey! So there were 4 balls placed into the goals and 2 balls in possession. So Team Superior Collisionist has scored a total of 18 points. So we're having a little bit of problem with some of the robots that are in the feed, so I think that this would be an opportune moment for me to discuss the many ways that robots do not work. So a lot of the hardware that we're using is just off-the-shelf, commercial stuff. It's not designed at all for a lot of the things that we're putting it through. So for example, a hard drive, which is just a series of spinning disks, is not designed to be shook around at all. It messes with the heads that are reading the data off of it. So we experienced quite a large number of failures associated with that. We've also been reintroduced to the ideas of gyroscopic motion. And when you move your hard drive perpendicular to the floor and your robot's spinning, the hard drive fails a lot faster. There are also other problems that we have. The lead-acid batteries, which are quite bulky. Right here, we get donated generously enough. Some of the problems associated with them, though, is that they are very, very heavy, and also that they have a relatively high internal resistance because they're somewhat old. This limits the amount of current that we can get from them, and makes it harder to drive motors, the computers, and all manner of other things.